Hello everyone. Nowadays, we are using all kinds of computers every day. Your laptop, MacBook, or your smartphone. You must have been wondering what happens in the startup stage of your Windows operating system, your Mac OS, or the mobile phones. In this short course, we will firstly introduce what is assembly language and machine language, the correspondence between them. Then we write our very first program in assembly language. In order to run this program, we need a program called assembler to translate our assembly program to an object file, and then use another program called linker to transfer this object file to the executable file. We are going to do all of this on a Linux Ubuntu desktop. I will show you how to do all of this step by step, from installing the Linux desktop, the most commonly used Linux commands, to the use of GNU assembler, GNU linker, and how to make a script file. We also cover a bunch of concepts: hexadecimal, disassembly, instruction set architecture, booting, power on self-test, read-only memory, legacy BIOS, master booting block, random access memory, interrupt, and ASCII character, etc. We will see how to do the compilation of the source code of the BOSHs and how to do the installation using the classical steps: configure, make, and make install. Eventually, we will run our first program on BOSHs. I guarantee you will learn the basic usage of lots of Linux commands and programs, understand better of the low-level computer technical concepts. From there, we will have the ability to explore more over the computer operating system. See you. Hey guys, in this video, we are going to write our very first program in assembly language. So the first question is, what is assembly language? In terms of computer languages, we can imagine such a picture in our mind that on the very bottom layer, that's the computer hardware, like the CPU, the memory, the video card, the audio card, the disks, the keyboard, the mouse, the monitor, and above that layer, that's called machine language. It usually consists of zeros and ones. So the machine language actually is just a bunch of zeros and ones. And the machine language is the one the CPU can directly understand and execute. And above the machine language layer, that's the assembly language. That's the one we are going to write. The assembly language is much easier to understand than the machine language. Say, if we are going to calculate the addition of two numbers x and y, in assembly language, we write add space x comma y. So it's very easier than understanding the machine language. And above the assembly language layer, that's the high level language we usually talk. You might have heard a couple of language names like C, Java, or Python, JavaScript, or C++. All of these are sitting a high level than the assembly language. Say if we want to calculate the summary of two numbers x and y, we can write some code like z equals x plus y. It's pretty much like the math formula, so it's very easy to understand. Below this high level, we call the assembly language the low-level languages. There is a very strong connection between the machine language and the assembly language. We also can say there's a very strong correspondence between assembly and machine language. As some kind of a conclusion, an assembly language is any low-level programming language. It is also often abbreviated as ASM. Some people also call it assembly language. Again, there is a very strong correspondence between the machine language and the assembly language. The machine language instructions can be executed directly by a computer's central processing unit or CPU. Actually, the smallest unit that the computer CPU can understand is the machine language instruction. Each such instruction causes the CPU perform a very specific task. You may have heard the term machine code. Machine code is a computer program written in machine language instructions, or it is translated from some high-level language like the assembly language. Great. I suppose we have talked enough concepts. Let's get to the real code. The one we are going to write is called the x86 assembly. We are going to write some x86 assembly code. This kind of assembly language is widely used and running on the current day's PCs. Okay, let's go back to our desktop and start writing the assembly code. Firstly, we create a text file. You can do it either on your Windows or on your MacBook. Let's name it first.s. The suffix .s here means it's an assembly code file. Let's open it. I just open it with Notepad. You can just copy what I'm writing and do the same thing on your computer. By doing this, the first time you can experience how to write the assembly code. We have finished the 13 lines of assembly code. That's all we are going to write today. I understand we still do not know much about what does this code mean, but we will go through all of these codes and explain how to run it, and also give you a good explanation on the concepts behind the whole things. But for now, we just save this file. Before we finish today's video, we create a folder and give it a name exercise and drag this very first file into the folder. Hey guys, in last video, we have written some assembly code and save it as first.s. We've also learned that only the machine code can be directly executed by the CPU. Now we've got a question. How can we translate the assembly code into machine code? Actually, there is a program can do this job. We usually call this kind of a program the assembler. There are a couple of different kinds of assemblers available, but the one we are going to use in this course is called the GNU assembler. It can be installed either on Mac OS or Linux or your Windows operating system. But in this course, we are going to install the GNU assembler on a Linux desktop. If you already got any Linux desktop, that's great. If not, that's still alright, as we are going to install a Linux desktop on your current operating system. Firstly, we need to install a program usually called hypervisor on your current Mac OS or Windows operating system. Then install a virtual machine or multiple virtual machines on the hypervisor. Then install the Ubuntu desktop, which is a Linux distribution on the virtual machine. Finally, we can install the GNU assembler or GAS on the Ubuntu desktop. So, in the following videos, we are going to firstly install hypervisor on your current operating system. There are many hypervisors available, but the one we are going to choose in this course is VirtualBox. Then we can install virtual machine on the hypervisor. Then install the Ubuntu desktop on the virtual machine. Eventually, we will install the GNU assembler or GAS on the Ubuntu desktop. Great, that's all of this video. See you in the next video.